Hi everyone, I'm Sin from Art Science Museum in Singapore. Thank you for joining us in this inaugural talk organized as part of a program of online lectures accompanying the exhibition Radical Curiosity in the Orbit of Buckminster Fuller. Presented at Art Science Museum in co-production with Fundación Telefónica Madrid and guest curators Rosa Pera and José Luis de Vicente, the exhibition considers the profoundly relevant legacy of one of the greatest minds of all times, Richard Buckminster Fuller. We're delighted to be presenting this opening lecture of Radical Curiosity, featuring the wonderful curatorial voices behind the exhibition. Rosa Pera is an independent curator and researcher. Her focus is on the strength of design as a transformation operating system through community action and its relationship with fields such as science, architecture, and contemporary art. Rosa has curated exhibitions such as On the Table Ai Weiwei, Out of Place, and Portable Culture. She was the founding director of Berwick Contemporary Art Center in Girona and former general curator of the Global Youth Culture Forum in Jeju. Rosa is currently the head of studies of the bachelor's degree in design at BAU, the Design and Arts College of Barcelona. José Luis de Vicente is a curator and cultural researcher. His work examines the current and future impact of social and technological innovation through artifacts, objects, and narratives that explore emerging social and political scenarios. Exhibitions which he curated included Big Bang Data, After the End of the World, Atmospheric Memory, Máquinas y Almas, Playtime Game Mythologies, and more. José Luis is the curator of Zona Plus D, co-founder of Tentacular Festival, and he currently teaches at the Institute for Advanced Architecture of Catalonia. Together, Rosa and José Luis will take us through the making of Radical Curiosity exhibition, the comprehensive relevance of Buckminster Fuller's ideas, and how his influence continues to make itself present today and in contemporary visions of the future. It gives me great pleasure welcoming them both for their talk.
Thank you. We're very happy to be here, finally, even if not physically. We hope that you are enjoying the exhibition, that a lot of people are actually discovering the fascinating world of Buckminster Fuller. In this presentation, we didn't want to actually make a tour of the exhibition because it's there and you can see it. We wanted to explore some specific narratives and some of the main ideas in Fuller's work and how has it influenced the world of today, the contemporary world. So we will discuss some stories and some key concepts to understand the full impact of his methodologies and of his projects. So I will bring the slides now. So it's possible that maybe of you are aware or are known of one of the most famous advertising campaigns of history, probably. It was a campaign by Apple Computer, the very important technology company, that was launched in 1987 and actually uses icons, portrayed very important icons of culture, of science, around this idea of thinking different. What maybe is not so well known is that in this famous spot, this is one of the famous spots of this campaign, there was like a gallery of icons that were all in a way representative of this notion of the capacity to think different, to innovate, and to change. And among many, many well-known historical figures like Martin Luther King, like John Lennon, among the gallery of heroes in this conference, there is this man, Richard Buckminster Fuller. Probably not as well known for the audience as the rest of them, but actually at this moment he was already an inspiration and a very important intellectual influence for the core of what we call Silicon Valley today, of the industry of technology and the development of the computer and the personal computer. So there is a lot in this story, and we can actually learn more about it through the work and through the words of Steve Jobs, who along with Steve Wozniak, in this very well-known story, started Apple Computer in a garage in which they developed the notion, what would end up being the personal computer, the notion of a computer for personal expression and not a computer for bureaucratic processes. So this is the whole Earth catalog. It's a very important publication from the 1960s. and is very well known for being one of the main instruments of the countercultural movement in the United States in the 1960s. The Whole Earth Catalog presented in its cover, in this famous first number, the first public image of the Earth. And it wanted to be as a collection of tools, a set of practices and methodologies that would help new communities to fund and to start new forms of thinking, new forms of creating community, and actually innovate and change the ways that communities were organized. And in a famous speech in a commencement speech at the University of Stanford in 2005, Steve Jobs said this. He made a very specific reference to this publication, the Whole Earth Catalog. He said, when I was young, there was an amazing publication called the Whole Earth Catalog, which was one of the Bibles of my generation. It was sort of like Google in paperback form 35 years before Google came along. It was idealistic and overflowing with neat tools and great notions. So he was already in a way calling this document the Google of their time. And the whole catalog was very much influenced by the work of Buckminster Fuller. In this first number, one of the things that you could find were instructions of how to build your own geodesic dome, which was something that the readers of the catalog wanted to know. The catalog was making a direct reference to Fuller as the inspiration of this publication, started by Stuart Brand. And in this process, a new generation of people, especially young people in the 1960s, were getting access and a very direct contact with the ideas and the methodology of Buckminster Fuller. So who were the readers of the catalog? There were at least two different set of people. One of them were the young people who in many cases started alternative communities, leaving the cities and setting themselves up in the countryside, and that were experimenting with new forms of community making. It was the Back to the Land movement in the 1960s, one of the biggest inverse migrations in history, migrations of people not going from the countryside to the city, but from the city to the countryside. And for these people, of course, the ideas of Fuller have been so influential that the geodesic dome was the shape that many of their houses would take. The new communities that they would start by creating and building these geodesic domes. Drop City in Colorado is one of the most famous ones, and it's a very long and complex story behind it. But there were other places where the ideas of the whole Earth catalog were also having an impact, like the first initial research institutions of what we would end up calling Silicon Valley, like this place, Xerox PARC. Xerox PARC was one of the first research institutions funded by the Cold War effort, in which some of the ideas of the development of these new tools would start taking shape. And this image is interesting because this is how some of these places could look like today, but definitely it's not how they look in the 1960s. In the 1960s, corporate culture was still very hierarchical, very top-down, very much defined by specific social codes that were not these ones. The idea of having meetings on beanbags was still a radical form of practice. And the engineers and the programmers who were starting to create the tools that we all use today were also reading and were having an access to the ideas of Buckminster Fuller through the whole Earth catalog that they would follow and read. It's interesting that this connection between the research institutes of what would start being Silicon Valley and the counterculture was already in a way present in the work of Fuller, because these research institutes were in a way founded by the Cold War effort. They were in a way actually at the places where technologies were being developed to gain an advantage in the Western-Eastern tension. And Fuller had always been in a way also in the center of this space. These are some of his most famous geodesic structures, the radomes. These were developed as a radar missile detection system in the Arctic. So they were part of the first line of defense in the Cold War. And of course, he had always had a very strong relationship with the US government, both developing tools for the army, but also the Department of Commerce, or in the top left image, this famous building that he developed along with Charles and Ray Eames in the US-Russian exhibition in the 1950s. That was one of the peaks of the Cold War. So in this mission, he was starting to think, and we were starting to look for the idea of new forms of relationship between what we call a designer, an artist, and an innovator. I mean, the ideas of innovation in technology, in economics, in social and political models could be fused with the ways in which artists and designers work in order to create a new form of practitioner that would actually have and would need new ideas. This is what he would call comprehensive anticipatory design science. In a way, the notion of to solve the challenges of the future using new tools like information, leading to new methodologies like data analysis and data gathering and data representation. We would be looking for a form of what he would call design science, that a combination between the capacities of science and technology and those of design and art, that would be all comprehensive. That means that it would include information from all different disciplines or from many disciplines, and that could be anticipatory. I mean, it could actually act before the effects of big global challenges would end up having an impact. In a way, it has been incredibly influential in our current contemporary ideas of what design is and how design can operate. Design today is not considered so much just the creation of objects or services, but also the production of methodologies for new forms of thinking, of new ways of actually changing organizations and changing forms of contemporary practice in organizations that actually can have a form of direct social impact. This is something that the design thinking world and movement reclaim, or that we see today in the practice of contemporary practitioners that exist in the space between art, science, design, and engineering. A lot of this had to do with Fuller's skepticism about politics. In a way, he was aware of the big challenges that the world faced: ecological crisis, housing crisis, population, unfair distribution of resources. But he was not a big believer in the capacities for politics to actually solve these problems. So instead of politics, he thought that in a way, the future will be solved by these new tools that we were developing, by the capacity of computers, the capacity of data production and data gathering and analysis, and by creating new forms of representation, new tools, and new methodologies. So in the 1940s, very early in his career, during the Second World War, Fuller started gathering data on the global production of resources and energy. This is what he would start to build up and end up calling his world resources inventory. And this was his effort to try to understand how to make the world work, how to make the world better, by understanding exactly what kind of resources we were producing, how we were producing them, and where, and who was benefiting from the production of global resources. For him, the only way that we could make the world better is to understand all of these processes in a comprehensive way and actually be able to manage them more effectively. So, for instance, these are some of the slides of his presentations that he will be using throughout the years, and looking at things like where are potential energy sources that are renewable, from wind to geothermal, what was the structure of the distribution of airways, shipping lanes on the sea, or even the global development data like literacy. And he would actually very early be representing the global distribution of these resources to understand and to try to understand what were the problems and how could actually they be allocated in most effective ways. In 1965, he initiated his project World Design Science Decade. This was a very wide scope project to try to, he presented to the World International Union of Architects to try to actually get all the work of design and architecture schools to focus on solving the systemic problems of the world for a decade. And here he compiled in a series of documents what he called his inventory of world resources. And you can see here some of the images of how he was representing the position of men in the world and in history, his position in the biosphere, our capacities for perception, how much of the world we can actually see with our senses, and how much of the world is not perceivable through our normal senses. So it's invisible, but it's real. It has an impact on us. Access to the atmosphere and to global water resources. And production. It's very interesting that he started to look at things like planned obsolescence. What is the life cycle of products? How long can they be useful? And actually the mining and production of minerals and materials, and how can actually make a best use of them. And these are all incredibly contemporary issues today. I mean, when we're looking at these things, we're actually looking at how today, in the 2020s, in the impact of the global ecological crisis, but also the need to produce new forms of producing things, we're having to have a very strict and very detailed look at how do the methodologies and how do the dynamics of material and the impacts of material in the world are today. Or production of energy, consumption of calories. These are many of the visualizations that he produced to try to understand how resources in the world were operated. And he also thought, and this was very important in his work, that we needed new ways of seeing, that the sources that we have to process this information were limited. So we needed to create new artifacts and new visual languages that would augment and would actually develop further our capacities to process this information and to understand it. So, for instance, this is one of his most epic, in a way, and extreme utopian projects. He would call this device the geoscope, and the geoscope was a sphere that would sit on top of the United Nations building in New York, and it would be an information display. It would be presenting real-time statistics and data on the production of global resources and the operation of global systems. And then this could be seen by everybody, and actually by seeing, then they would understand the impact of these processes in the contemporary world. So in a way, he was already building, through his fascination with the computer and his fascination with representing resources, he was trying to create new ways of seeing through new technologies. And this is probably the most famous of the buildings he developed, the US Pavilion at the Expo of 1967 in Montreal. The building would become a symbol for his most well-known invention, the geodesic dome. But in his initial proposal for this project, he was going to develop not only the exterior of the building, but also the contents. And in the content, he would locate what he would call the wall game. The wall game was one of his most ambitious projects. It's a project he would develop throughout most of his life. And basically, the idea was really to use a big computer like this one and a big information display that would allow visitors to see in real time the representation of the flows of materials, energy, global systems in operation. And then, as players in a game, they will be able to assign and to distribute the location of these resources, because the goal would be to, and this will be the goal of the world game as a system, to make the world work for 100% of humanity in the shortest possible time through a spontaneous cooperation of all people involved, without ecological offense or the disadvantage of anyone. For him, the idea of how would we solve the problems of the world was to create in a game of a spontaneous cooperation that we would call today a non-zero sum game. That is a game where everybody can win, that there is no need for someone to lose in order for the other to win. Of course, the project of the wall game as a big computer system was never developed, but he uses methodology in multiple workshops throughout the decades, with the support of supporters like Mercedes Mather and in an education environment and schools. In these ones, he would run and play and simulate the possibilities of the world game to be a methodology to try to understand what are the global problems of the world today. And of course, he wouldn't find a solution. The world game could not be solved successfully necessarily, but it was a great debate tool and a great provocation to try to understand why are we still in a system where resources are allocated inefficiently, but also we are stuck in zero-sum game dynamics. That is, in systems where in order for someone to win, someone has to lose. So these are images of some of the wall game sessions that he would develop throughout the years. Fuller was an incredibly successful inspirational speaker. Throughout the last part of his life, he would travel the whole world. He would make it everywhere, including Singapore, to spread his ideas. And it's his ideas, in a way, would have ended up being more influential in multiple fields today. Have been very influential in design and architecture, but also, as I've been trying to narrate in this presentation, they have been actually instrumental in creating a specific ideology and a form of looking at problems through information technologies and through the movement of information design and disciplines that appear many years later and that he would have been fascinated with, like big data analysis, like machine learning, and like data visualization, to try to manage and solve the problems of the world. When he's thinking about making the invisible processes readable, he would probably already be able to imagine our contemporary narratives about how we will solve the problems of the world through sensors, through data analysis, through algorithmic analysis and calculation. And of course, these have not solved all the world problems, but it has given us pointers, it has given us starting points to try to understand better how we can make the world work for 100% of humankind. And I'm going to pass the word to Rosa, who's going to continue from here with her presentation exploring other spaces of the world of Buckminster Fuller.
Okay, thank you, José Luis. One of Buckminster Fuller's skills was knowing how to condense his knowledge into highly informative and inspiring quotes, like this one. He said, I've often heard people say, I wonder what it would feel like to be on board a spaceship. And the answer is very simple. What does it feel like? That's all we have ever experienced. We are all astronauts on a little spaceship called Earth. Fuller's mission as a visionary crew member of that spacecraft was to make the world work 100% for 100% of humanity without harming the planet or creating inequalities. His message was, we are all responsible crew members and not just travelers or tourists on a spaceship Earth. To carry out that mission, Fuller promoted a design science revolution. A revolution to change the world through two areas of knowledge in dialogue and permanent action, design and science, and also with other disciplines such as philosophy or art. Fuller does not rely on specialization, but rather promotes transdisciplinary knowledge. That is why he defined himself as an anticipatory comprehensive designer scientist. Beyond his specific projects to change the way of living in aspects as specific as housing or mobility, Fuller was busy generating new methodologies and tools, new devices to change models and new imaginaries on which to project other futures. Bucky understands that the world is spherical, as we can see in this drawing that we can see here. That the world is spherical and in motion, and that we have a wrong perception of it. It is necessary to change the concepts and the representation of the world in a radical way. He is concerned with words, the terms that name things. An important concept to him is lightful, as we can see in this drawing, referred to light and lightness, to energy and knowledge, in a sort of science and metaphysics mix. For Fuller, to change the world, it is necessary first to change the perception of it, and then the knowledge related to it and the management, how to manage the world. I am going to talk about Fuller's research methods and how he transmits his ideas throughout his career, which crosses disciplines, audiences, and situations. Thus, architecture, engineering, metaphysics, art, and throughout it all, design. The science design revolutions carried out by Fuller, or Bucky, as he was well known, is articulated around three axes. Housing, which he called shelter and which connects us directly with nature. Mobility, which he also linked to nature through biomimetics. And education, the most important area from him in terms of the future. And it is precisely in the field of teaching where Fuller coins and disseminates some of his main ideas and concepts to articulate thought and action through new models and procedures. One of the concepts coined by Fuller is that of ephemeralization, that is doing the most with the least. This concept is connected with efficiency and is developed in the progression of his projects on housing, the Lightfoot houses, the 4D house, the Wichita house, and domes. The exercise that Fuller proposed in 1948 to his students at the Chicago Institute of Design is very interesting. It consists in the compilation of the furniture, appliances, and accessories needed for a standard home with 6 inhabitants that should be encapsulated in a 2.40 by 2.40 by 7.60 meter trailer. Another concept coined by Fuller, central to his ideology and practice, is tensegrity, a neologism that combines tension and integrity. It consists of the suspension of rigid elements in space exclusively through tension by continuous tension and discontinuous compression, as we can see here with the action with Fuller among his students. On this axis of mobility, Fuller's revolution will be carried out through the dynaction car, a 3-wheel, 6-meter aerodynamic car capable of transporting up to 11 people. For its design, Fuller connects the knowledge of science and art and receives the help of Sterling Burgess, famous naval architect and aircraft builder, and also the artist Isamu Noguchi, who made the first wooden models. As I said, education is a priority area in Fuller's revolution. Children, says Fuller, are the first scientists because they experiment and wonder how the world works. Education must be understood as the system that allows reconnecting with innate scientific attitudes without limiting or erasing them. This is why Fuller declares himself an enemy of all specialization, because according to him, what must be achieved is to have a comprehensive knowledge of the world, of its totality and not its parts, without understanding how the whole system works. Fuller will develop it as a teacher through workshops and long conferences around the world, and in a more stable way in Carbondale, in the Department of Design of the Southern Illinois University as visiting lecturer and research professor, where taught the subject generalized design science exploration from 1959 to 1971. Let's talk about Fuller's research processes and how they led him to create his own devices to explain himself and to protect knowledge and ideas to the world. One of the words that best define Fuller is experimentation. He practiced and promoted throughout his life, interacting with creative minds from fields as diverse as engineering, physics, architecture, biology, and the arts. Throughout his career, Fuller always surrounded himself with experts, professionals, and students. And artists were very important figures for Fuller, and without them, it is not possible to talk about Fuller's work. In his career, 2 moments of impact stand out in the encounter with important artistic scenes. In the 1930s, the Romany Mary Tavern, led by the Romanian Marie Marchand in the Greenwich Village in New York, where he conceived with artists such as Isamu Noguchi, Brancusi, or Marc Chauvet. And in 1948, at Black Mountain College, an innovative institution with a horizontal organizational structure and an alternative teaching system based on experimentation. Directed by the painter Joseph Albers, Black Mountain College welcomed Bucky and such prominent figures as the visual artist Annie Albers, the musician John Case, the dancer and choreographer Merce Cunningham, the architect Walter Gropius, or the painters Wilhelm and Elaine de Kooning and Robert Boderwehr. And here we can see the work of Ruth Asawa, also that was a prominent student at this school. Aside from the concepts he coined, Fuller's innovative spirit was also expressed throughout the devices he devised. I will talk about some of them, essential to know to what extent Fuller needed to invent instruments to transmit his knowledge and ideas, those of a man born in the 19th century, but who worked with ideas of the 21st century with the instruments of the 20th century. The Tetrascroll is the title of the 3-dimensional publication that Buckminster Fuller, now in his 80s, made together with the engraver and editor Tatiana Grossman to convey his ideas about the universe empirically and scientifically, as he said. Based on the tetraedron, this artifact expresses Bucky's ideas about time, physics, synergy, and the cosmos with 21 lithographs divided into 26 sections, each forming an equilateral triangle. He made the drawings directly on the engraving stone while explaining his theories that, transcribed, accompanied the illustrations. The origin of Tetrascol is the drawings that Bucky made in 1931 for his daughter Allegra when she was convalescing, to explain Einstein's theory of relativity through a very personal version of the story of Goldilocks and the Three Bears. Another of the contexts that define Fuller and his work is dimaction, a trend of his main projects and that arose from the union of three notions present in all his thought: dynamic, maximum, and tension. 12/1 is another of the devices that Fuller created to convey his ideas. It brings together his main projects and consists of the overlapping of his patents, images of the projects, and acetate sheets with the main data in each case, an instrument and a method that he will use in other contexts, such as in the workshops on the wall game. Projected on an icosahedron, a 20-side polygon, the dimaction map is more accurate to the site of the continents than the Mercator projection, which is used globally and throughout history, and even today. Fuller's great innovation is to present the continents as an island in the middle of the ocean, a continuous land surface. Additionally, the dimaction map can be developed in multiple ways and dispenses with any notion of north and south, east and west. It is an essential device to understand the world, essential in turn in all Fuller's work on information, as such the world game, and in his innovative ideas on education. In Fuller's education system, each child will have a learning unit, a space with a closed TV circuit, access to a tutor, and with the dimaction map as the main element. The dimaction map is in turn connected with the do-it-yourself philosophy that emerged strongly in the 60s of the 20th century. Fuller involves different agents in it, from his collaborators, students, and very diverse audiences. Everyone is invited to build their own pocket map. It is, therefore, another of the devices that Fuller generates to change the perception of the world, and with it, the corporality of people in relation to it, as crew members and not only as travelers. Similarly, the most famous project generated by Fuller, the geodesic dome, goes viral and its massive construction. With self-built kits, everyone can have their own geodesic, designing their own version of it. At the other end of the spectrum, we find key concepts such as synergy, the core of Fuller's thinking and practice. The notion of synergy connects his vision of the universe with the methodologies to be applied for the sustainability of the world. Synergy is the behavior of whole systems that cannot be predicted by the behavior of any of their separate parts. One of the strangest Fullerian devices, it is a non-book that stores a vast amount of highly expert knowledge. Together with Fuller, Edgar Jarrett Applewhite is the one who devotes the most efforts to clarify the meaning and importance of synergetics, the area in which Fuller will develop a great mathematical knowledge, highly precise and advanced to understand and explain mathematically and philosophically the functioning of the energies of the world, nature, and the cosmos. He said, "Universe is a synergy of synergies. In order to really understand what is going on, we have to abandon starting with parts, and we must work instead from the whole to the particulars. There is nothing that one does that does not affect all others in a varying degrees. This, of course, includes all life." Applewhite collaborated with Bucky on the books Synergetics 1 and Synergetics 2 and compiled on a Tupperwriter, not a computer, one of the strangest books in philosophical history, the Synergetics Dictionary. It is a 4-volume photocopied collection of over 20,000 note cards used during his work on synergetics. In the cards, Applewhite summarized Buckminster Fuller's thoughts on hundreds of topics that appear in published and unpublished letters, books, tapes, and articles. It is a very complex job, a challenge due to its almost impossible taxonomy, especially before the internet appeared. Without a doubt, the most genuine device created by Bucky was the Dymaxion chronofile. It is the file generated by Fuller since 1927, and that stores all the documents and data that passed through Fuller's hands and mine until his death in 1983. The Dymaxion chronofile started in 1927, when Fuller was depressed by death of his first daughter. His projects did not well, and in a moment of depression, he thought of taking his own life by throwing himself into Lake Michigan. But as he himself told countless of times, at the last moment, he had an epiphany and understood that his life did not belong to him. So he decided to dedicate it to improving the world. It was then that he decided to keep all the documents. The Dymaxion chronofile is preserved at Stanford University and contains more than 140,000 items, such as sketches, letters, photographs, prescriptions, flight tickets, or invitation cards from educational, scientific, and social institutions around the world. Finally, as the inscription of Fuller's tomb shows, he himself understood himself as a device. Call me Trintap, it says. And it is a powerful metaphor. Fuller saw himself as a Trintap, the tiny device that is being installed on large ships and that, when activated, agilely change the course of its many-ton body. I will finish with a phrase that summarizes one of Fuller's maxims and that I think comes in handy to think about in the times we are living through a climate emergency and war, with the challenges that have to be faced and that call for a radical change, in the line that Fuller promotes. Humanity has the option to become successful on our planet if we reorient world production away from weaponry, from killingry to livingry. Can we convince humanity in time? That was the question that Bucky said at his time. And I think that is very important to think about it just right now when we are facing this horrible war in Ukraine. Thank you.
Thank you so much, Rosa and Jose Luis, for helming this opening lecture of Radical Curiosity, taking the time to walk us through the making of the show, and sharing your insights into the core ideas, projects, and precepts in Buckminster Fuller's work. There are always so many ideas to investigate and questions that come up as curators work on an exhibition's premise and central theses, planning out the narratives and chapters, building the collection for the show, and working with collaborators to shape the project as it develops. So I wonder if I could ask both of you if there's a specific part of the process or your research that holds particular meaning as you were developing this exhibition.
Okay, for me, one of the main discoveries was the interest that Bucky had in education and all the ideas and methodologies he developed around this. And also the transdisciplinary approach of his thoughts and methodology during all his career. No? I think it's very important, and that this connects today with this antidisciplinary approach that has many of researchers and artists and designers, as we can see through the work of, for example, Neri Oxman, who is one of the designers and researchers we have in the exhibition.
What about you, Jose Luis?
Well, I mean, it really was a challenge because something that we really discovered was that Fuller's universe is so big that this is one of the multiple exhibitions that could exist on him. And almost in any single of the chapters of the show, in any of the projects, there could be like a full exhibition around that set of ideas. For instance, like when Rosa was mentioning synergetics, like the world of synergetics is huge. It's very difficult to grasp in itself. So this quality of the work of a figure that will be revisited again and again and again is really fascinating because there is so much there still to explore. And when we were looking at the contemporary problems of the day, from the management of resources to the climate crisis, to problems that are still having an impact in every city in the world, like housing, it was very interesting how we could always find a reference to that. We could always find some sort of writing, some sort of quote, or some projects, some of them very well known, others not so well known, that was in a way already anticipating that. So it's incredible how present his ideas are still in our contemporary discussions every day. And as Rosa was saying, his focus of thinking that we can move away from violence and non-zero-sum gains and war into a world of other forms of problem solving, conflict solving, and resources management is incredibly prescient and important and vital today.
And as a closing note to the program, would you share what the impetus behind the Fuller exhibition project was and what you might like or hope people to take away from their encounter with this show?
Yes, I think that first of all, the sense of responsibility we have towards the planet and nature and society, no? How we can live and think all together, no? And all together are women and men, but also animals and technology, no? We are all at the same time activating the world, and we think and we must think all together, no? How it is working and how it have to work in the future, right? Because future is now.
Yeah, I think that's something that was also very important. And the more I revisit the show, the more I think about it, is that there's like this attitude, this constant optimist possibility of thinking that things can be changed, that actually there's a possibility for implementing major change. We have gone through some pretty dark years in our collective conscience, I think, and actually we haven't gone through very optimist years in our belief in the capacity for change and from reinventing things for the improvement of everybody's conditions. And there is something there that I think is very urgent to reclaim, that we cannot be stuck in this constant concern from global crisis to global crisis to global crisis without thinking in terms of change being possible and the imagination and creativity having an essential role in change making.
Yes, a radical imagination, no? As maybe Bucky could say, no?
Yeah, we also very much hope Radical Curiosity offers this invitation and a provocation to our viewers and visitors as well to observe, to ponder on, and to challenge the world around us with the same sense of curiosity. A wonderful thanks to everyone who has been spending your time with us, with Jose Luis and Rosa across the duration of their talk. The next lecture in the series, The Future is Always First an Idea, will be headlined by Principal and Director of Safety Architect Singapore office, Charu Kokate, who led on and oversee the construction of iconic and complex structures, including Jewel Changi Airport and Marina Bay Sands Integrated Resort, which Art Science Museum is part of. Charu will speak about the studio's projects that embrace the philosophy of comprehensive and humane design, and discuss the role of speculative work and collaborative placemaking in urban design and architectural practice. Our education specialists will also be guiding experiential tours of Art Science Museum's building. And while our museum is conceptualized and designed by architect Moshe Safdie, it's dedicated to the dynamic interplay between art and science. And Moshe Safdie is one of the many architects Fuller inspired. So in addition to exploring the green features and thinking about how the location shaped its architectural plans, these tours would also trace how Fuller's vision comes full circle at Art Science Museum. Our education specialists will also be leading regular guided tours of Radical Curiosity, where they will also be sharing about the series of interactive learning and hands-on activities developed by the education team, bringing Fuller's key projects to life. We do hope you get a chance to visit the exhibition, which runs until the 10th of July, and join us in some of these companion programs if you're able to. You can also stay up to date with everything that's happening at Art Science Museum via our website, Facebook page, and YouTube channel. And we hope to see you again. And finally, thank you so much again, Jose, Luis, and Rosa. Please keep well, and we wish both of you our very best for your forthcoming projects.
Thank you.
Thank you.